Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PL/SQL developer just like you. This lesson is the latest in my series on writing dynamic SQL in Oracle PLSQL programs, and the focus of this lesson is executing DDL and simple DML statements, that is, Method 1 dynamic SQL. The agenda for this lesson: I'll start by talking about what is DDL, what is simple DML. We'll talk about then using execute immediate native dynamic SQL to execute DDL statements in PL/SQL. We'll take a look at also using DBMS utility execute DDL statements, managing the impact of dynamic DDL, and then executing simple DML dynamically. So, what is a DDL statement? A DDL statement is a data definition language statement. That means that it affects the definition of the database objects in your schema. For example, create and drop tables, create and drop PL/SQL program units, alter database objects, etc. Anything that modifies the structure of the underlying objects in your database. And note that whenever you execute a DDL statement in your session, it automatically performs an implicit commit. Something to always remember about DDL statements: no matter where they're executed, they will perform an implicit commit. And you cannot natively execute DDL statements in PL/SQL blocks as a static SQL statement. Let's take a look at that. In fact, let's close out all these other files until it's time to look at them. And let's open up the static DDL and PL/SQL. So here's a PL/SQL block, and I'm going to try to create a table right inside that block. And when I run this code, Oracle tells me basically, I have no idea what you're talking about, and counted the symbol create. Create is not a statement allowed in PL/SQL. It's a part of the DDL, the data definition language, and that's not available for native execution in PLSQL. Well, what if you want to do that? What if you need to create a table dynamically? You'll do it with dynamic SQL, and we'll come back to that in just a moment. Now, what is a simple DML statement? Simple DML and DDL are the statements that are executed in the Method 1 dynamic SQL format. And in the context of dynamic SQL, a simple DML statement is one in which you are not binding a variable value from your program into the DML statement via a placeholder. And a placeholder is indicated in a dynamic SQL string by a colon followed by a string, either digits or a valid PL/SQL identifier. Okay, let's take a look at some examples. Here's an example of a static DML statement. In other words, I can simply execute this update statement directly in my PL/SQL code or outside of PL/SQL. I'm going to give everybody in my employees table a 25% increase. Nice. So that's static DML, nothing dynamic about it. Here's a dynamic DML statement that is also simple. So I've got an update string. I'm going to concatenate the name of the table. Maybe it's employees, maybe it's my employees, maybe it's your employees. And I'm going to give everybody a 25% increase. Notice that's also inside a string. So this is dynamic SQL, dynamic DML, and it's also simple because there are no placeholders. Here are some examples of dynamic DML with placeholders. So I'm going to update the specified table, and I'm going to set the salary equal to salary times a multiplier, but I don't hard code the 25% increase here. Instead, I use the colon and then a name, or I can use a colon and a number. So the placeholder is a place where you can actually use a number like 1, 2, 3, or 1 as a quote-unquote name. Usually in PL/SQL and Oracle, you have to preface a name with a letter. So there's a slight exception here. So this is an example of a placeholder, but what we're going to be talking about in this lesson are the DML statements in which you do not have placeholders, no bind variables. You simply execute a string that's constructed at runtime. Okay, So let's take a look at executing dynamic SQL statements, or dynamic DDL. And what it comes down to is using execute immediate. So execute immediate is the main statement used as a part of the native dynamic SQL operation added in Oracle 8i. And all you do is execute a string in the simplest form. You're not binding any values. You're not retrieving data back from the SQL statement and putting it into the calling block. None of that. You're simply executing the statement. Very simple. Let's take a look at some examples. And these are all examples of dynamic DDL execution. All right, first of all, drop whatever. One of my favorite dynamic DDL programs. So the program drop whatever allows me to drop pretty much anything I want in my schema. Really, really easily. In other words, it's an extremely dangerous program. I pass in the name, and I can wildcard it. I pass in the type of object I want to delete, drop, and I can wildcard it. And I can specify, and by default I am just checking. I'm not really going to drop. In my program, I find all the objects that match the specified parameters. It's like the name, it's like the type. And then, with a cursor for loop, I construct my drop statement. Here's a dynamic DDL statement. Drop the specified object with the specified name. If it's a table or an object, add cascade constraints. You can have all sorts of fun here. And then, if I'm not just checking, I will execute immediate my drop string. And that's it. There's the entire part of this code. That's the actual dynamic SQL execution. Simply pass it the string, and it executes it for me. And then I'll show whether I succeeded or failed. Well, let's give it a try. Will it compile? Yes, my code compiles. Let's go back to my schema browser. And let's look for, tables that start with the word temp. Do we have any temps here? Have I already gotten rid of all those? No temps. But here's a table that starts with the word table. Let's get rid of tables that start with the word tab. Okay, so what I'm going to do is construct a block. I'm going to call drop whatever. I'm going to say I want to get rid of anything that starts with the word tab of type table. And what the heck, I'm going to say I only want to check, which is not a bad idea when you're doing drops. So I execute this program, and it shows me that it would drop tab 1, table of numbers, table with X rows. Notice just checking. So now I'm going to say, good, I really want to get rid of that stuff. Run my script, and it successfully dropped 3 tables. So drop whatever is a very powerful, flexible utility, and I like to show this because it highlights 2 great things, or 2 important things about dynamic DDL. Number 1, you can create really excellent utilities that do lots of work for you without having to manually do each step independently or manually. And second of all, it's an extremely dangerous, powerful tool. So be careful about how you ever write and run dynamic DDL operations, especially as stored program units. You're probably never going to use drop whatever, but what you might want to do is take this program, show it to your DBA, and say, look what I learned in my class today. And here's a great utility you can use, and they'll probably have a heart attack. Okay, so that's one example. Let's take a look at create index. Here's a very simple program that says take the index name, the table name, the list of columns, and it simply constructs the create index statement and runs it. So nothing fancy here, probably not a terribly useful generalized utility. For example, we don't allow them to specify whether it's unique or not, but it demonstrates again that you can construct these statements and execute them on the fly. Set trig is probably a more interesting utility for you. You might want to disable or enable all the triggers on a specified table, and this program will do it for you. Specify the table, the owner of the table, and the actions you want to enable or disable. It finds all the triggers on the table, sets up or defines the alter trigger statement, and then executes it. So that's something you might actually find useful in your environment. Create user. What if I need to create a user on the fly dynamically to build some scripts or to run some tests? I connect as my sys account. Oh no, now you know my sys password. I hope you don't crack into my laptop. Here's my create user program, Execute immediate, first I'll drop the user in case it already exists. I check to see if the user does not exist, in which case I don't care. That's good. That's the negative 1918 error. If anything else goes wrong, I want to raise an error and not continue. And then I will create a schema granting session and resource to my user identified by the same name for the password and so on. So this script will allow you to create users, grant additional privileges, and so on. And let's see. Let's take a look at the last two, DBMS error log helper and execute DDL in file. Now DBMS error log helper is a script that I wrote to help you use the DBMS error log package and the log errors feature. So check out the error management lesson or series and the DBMS error log and log errors feature to learn more about this feature and why you'd want to use this package. But the bottom line is that within this package I say I have a create objects program, and in it I do lots of dynamic DDL. I drop the error log table if it already exists. I call a built-in program from Oracle that actually does dynamic DDL itself. It creates an error log table. I use dynamic DDL to alter my table, adding columns. I use dynamic DDL to create a trigger to populate those new columns. I generate and compile a package. All of this is dynamic DDL. The bottom line is that dynamic DDL gives you an incredible amount of power and flexibility that you can use in a very wide range of ways. And finally, exec DDL in file. This is my most generic exec DDL program, and it basically says, hey, you've got something like the DBMS error log helper package. You've got a file that's full of a DDL statement. In fact, two: create a replace package, create a replace package body. These are DDL statements. This program, exec DDL from file, will read the contents of your file, load it into an array of strings, and then use, in this case, DBMS SQL to execute the statement dynamically. Now, I haven't shown you DBMS SQL yet. We'll be coming back to that in the advanced topics. So in this case, I'm using a different mechanism to execute the DDL statement. But the bottom line is it's the same effect. Dynamically execute DDL statements. Okay, so lots of different examples. I encourage you to play around with all of these. Well, I'm not sure about play around. If you have a little schema or a little database instance in which you can build things and destroy things at will, then go ahead and do that. Otherwise, you might just want to look at the examples and make sure that you understand how they work and what they do. Oracle does offer an alternative to execute immediate for executing dynamic DDL statements. The DBMS utility package has a built-in called exec DDL statement, and it will simply do the same thing as execute immediate with a string. And the statement executes under the authority of the schema from which the procedure is called. So even though the package is owned by sys, don't worry, you're not going to be executing the DDL statement under sys's authority. And other than that, it's pretty much the same thing. I can simply say exec DDL statement, create table, drop table, etc. When I run the script, I'm going to get an error. Notice missing left parentheses. Note my create table statement is not complete. I don't specify my columns. And so the point I wanted to make here is that if I execute my DDL statement dynamically, I'll get the same error that I would if I was executing it statically. It will just propagate it out inside my PL SQL block. I can trap the error. I can do something with the error, but it will be the same error that I would have gotten otherwise. Okay. Let's talk about some common problems or complications with dynamic DDL. As I mentioned before, it always performs an implicit commit, so make sure you can account for that. You'll be dealing with that in your code if that makes sense. Otherwise, you might consider using an autonomous transaction to narrow the scope of that commit, the propagation of the commit. I'll be talking about that more under best practices for dynamic SQL. Generally speaking, you want to use dynamic DDL with great care, since a DDL change not only performs a commit, but can also cause a ripple effect of invalidations of your program units. Any database object dependent on an object that you changed with dynamic SQL will cause invalidations. Second of all, and this is much more subtle, you might get insufficient privilege errors. In other words, just because you can do something as static SQL, a static DDL inside your schema, doesn't mean you can do it as dynamic DDL inside a stored program unit. because when you execute inside a stored program unit, sorry, this should say inside, not outside your stored program unit. If I create a stored program unit, a procedure that executes a DDL statement, then I will need directly granted privileges for that to work, or compile my program unit with invoker rights. Lots of details there. Let's take a look at a script that verifies all of this, demonstrates it. So my file, DDL insufficient privileges, first of all, connects as my sys account and doesn't allow Scott to create tables. So I revoke create table from Scott. And I'll also revoke a role called create table in case it's there. I will make sure that Scott can create procedures. So Scott cannot create tables. Okay, then I'll connect to Scott and I'll see, can I create a table? And I'll try to do it with static DDL, and I'll try to do it as dynamic DDL inside a PL SQL block. Then I'll go back to my sys account. I will create a role called create table, which has the ability to create a table, and I will grant that role to Scott. I'll go back to Scott, and I'll see if I can create a table with static SQL. I'll see if I can create a table with dynamic DDL inside an anonymous PL SQL block, and then I'll create a procedure that does the same thing, create a table dynamically, and I'll see if I can do that. Now, this procedure is actually an authID definer rights program, which means that it's compiled and executed under the privileges of the owner of the program, Scott. And then I'll try it again with invoker rights. So I'll recreate the procedure with my authID set to current user, and now it runs under the privileges of the invoking schema, and role-based privileges are allowed, and I'll see if I can create a table. And finally, I'm going to go back and grant a directly granted privilege to Scott. Then I'll go back to Scott, and I'll try to create the procedure even with its set to authID definer rights. That's a lot. Let's try it out. So what I've done is start up my SQL Plus session. I'm going to grab all this code. I'm going to run it inside SQL Plus. I've created a spool file. Let's check out the spool file. Let's remember what the spool file name is, dynamic DDL. Let's take a look at what happened. Okay, so I revoke create table from Scott. Then when I connect to Scott, when I try to create a table, whether it's directly inside SQL Plus, whether it's dynamically, I cannot do it. Insufficient privileges. That makes sense. I have no privileges to create a table. Okay, I go back to sys and I say, all right, let's let you create a table, but only through the create table role. So role-based privileges. No directly granted privileges to Scott. I go back to Scott. Can I create a table? Absolutely. Right inside SQL Plus. Can I create a table with dynamic DDL? Yes. No problem. But notice this is a top-level anonymous block. And the problem then is when I create a stored procedure with authID definer, which is the default inside PL SQL. So I create a stored procedure and I try to create a table. Then when I try to do that, I get insufficient privileges. Because with definer rights programs, which is how most of our programs are defined, with definer rights programs, the program has to execute only with directly granted privileges. No role-based privileges are allowed. So I don't actually have the privileges yet to create my table. However, if I change my definition to an authID invoker rights current user, then Oracle will let me use role-based privileges and I can create the table. But notice it says name is already used by an existing object. So it didn't actually create the table, but clearly it could have. It simply was not able to because the table already existed. Finally, I'm going to go back to sys. I'm going to say, okay, Scott can create tables with a directly granted privilege. I go back to Scott. I create my procedure, create table proc, authID definer rights. And then when I create my program, when I try to create my table, it says, no problem. You were able to create the table. So there are clearly lots of things going on here. Role-based privileges, directly granted privileges, authID definer, authID current user. We're not going to be getting into invoker rights in this series, you'll want to take a look at my Managing PL SQL Applications lesson series for details on that. But the point is, as soon as you work with dynamic DDL, you might encounter a situation where the process, the statement that you wanted to execute, let's go back to the code, you find that you can do this. I can create my table inside my schema in SQL Plus or wherever else in Toad, no problem. But when I try to use it, when I try to do the same thing inside a PL SQL program unit, I get an insufficient privileges error. If you find that happening, it works outside of PL SQL, but inside PL SQL it doesn't work, then chances are the problem is you need directly granted privileges, or you need to change your program to use invoker rights, auth ID current user. So that's the thing to look for when you run into insufficient privileges. Let's finish up by taking a look at executing simple DML dynamically. There's nothing to it really. You just execute the string, same as dynamic DDL, but it's even simpler here because you don't have to worry about as many side effects as DDL. And after you execute the string, if you'd like, you can check the contents of SQL%row count to determine the number of rows modified by your statement. So this attribute, this implicit cursor attribute, will apply to the most recently executed dynamic SQL statement as well. Here's my example. I execute immediate. I construct my dynamic string, my DML statement. I have a dynamic table name, but I have no placeholders, no colons. And then I'll take a look at the value returned. Let's try it. Same thing I just showed you. Afterwards, I'm going to roll back because I don't want to keep this change in place. Run my script, no errors. And I updated 107 rows. Now let's see. Why is that? Because the employees table has 107 rows of data. So it updated every single row in the table as I asked it to do. So that's simple DML. Just construct the string, pass it the string, execute it, and then take a look at the impact. Either an exception was raised, or you can look at the number of rows modified. Conclusions. Dynamic DDL is a very powerful tool. There's so much you can do, but use it with care. There are so many potential dangers. The ripple effect of invalidations, privileges issues, implicit commit. The simplest DML, in other words, no binding of variables, can be handled very simply. And in fact, also the dynamic DDL is very simple. The actual execution of the statement is a no-brainer. The impact of the execution of the statement and the construction of the statement is where you run into complications. But simplest DML is handled very, very simply. It's also quite rare. It's unlikely that you're going to have very many DML statements that you're executing dynamically that do not have or should have bind variables. Most of them will need and should have bind variables. But in this case, anyway, it's simple enough.